Welcome back, everyone. Today we are going to go through the proof of the difference of signs sum to product identity. So let's dive in. All right, so the first thing I'm going to do is I'm going to define C. Let's define C as A plus B divided by 2. And then let's also define D as A minus B divided by 2. And the reason we're doing this is because notice that in these sets of brackets, we have A plus B divided by 2 and A minus B divided by 2. So now what we're going to do is we're going to write these A and B in terms of C and D individually. Okay, so for this first one here, if I multiply both sides by 2, I get that 2C is equal to A plus B. And I can do the same thing with D, that 2D is equal to A minus B. Therefore, if we then solve for A for both, we're going to end up with that A is equal to 2C minus B. And over here, A is equal to 2D plus B. Then I'm going to add the full equations together. So let's say this is equation 1, this is equation 2. I'm going to add 1 plus 2. So on the left, we would get A plus A, which is 2A. And on the right, we would get 2C minus B plus 2D plus B. The plus B and minus B cancel each other out. And we end up with 2A is equal to 2C plus 2D. And then if we divide by 2, we get that A is equal to C plus D, like that. And similarly, if we were to solve for B in both equations, so going back to this step here, we get that B is equal to 2C minus A, and B is equal to 2D plus A. Or sorry, no, that's not quite right. Yeah, so we're looking at this one here. We're trying to solve for B. So if we add B to both sides, we get that B plus 2D equals A, which means that B is equal to A minus 2D, like that. Then if we add these together, we end up with 2B is equal to 2C minus A plus A minus 2D. So if we cancel out those A's and divide by 2, we get that B is equal to C minus D. So there we go. All right, so the next thing we're going to do is we are going to recall our identities related to addition and subtraction as well, right? Because notice here on the left side of our original identity that we're seeking to prove here, we have sine A minus sine B. And so sine A minus sine B, based on what we've done so far, can be rewritten as sine of C plus D plus sine of C minus D, right? Because all we're doing here is we're plugging in this equation and this equation that we found, okay? Then I'm going to apply the addition and subtraction formulas for sine. So recall that the sine addition formula is sine C plus cos or times cos D. So this is going to be sine C cos D, like that, plus cosine C sine D, right? So this one here, I want to be clear, this is the identity replacing sine C plus D here. Okay, and now let's figure out for this one here, this is the difference formula. So this is going to be sine C cos D minus cos C sine D, right? So this relates to this one. Okay, now I'm going to cancel out cos C sine D and minus cos C sine D. And I'm going to add these two together and get that this is equal to 2 sine C, there we go, cosine D, like that. And now all we need to do is substitute C and D back in. So recall that earlier we stated that C is equal to A plus B divided by 2, and D is equal to A minus B divided by 2. So I'm going to sub those back in. We're going to get 2 sine A plus B divided by 2 cosine A minus B divided by 2, like that. And there we have it. There we go. All right, as always, if you have any questions, please feel free to leave those in the comment section, and we'll see you for the next one.